Okay, now let's talk about surface area of a cylinder. We're going to use what we just talked about in 12.2, the surface area of prisms, all the definitions. We're going to use all the same things, all the same equations, everything. And then we're going to make some slight modifications to the end result equation so that we can use them for circles and for cylinders. Okay, so first of all, cylinder. What's a cylinder look like? I gotta get one out here. A cylinder looking like this. It has two sides that are congruent. So it happens that the two sides are circles. Okay? Bases. I set it on the base. I don't have to set it on the base. I can set it like that and let it roll around. Now it has a lateral surface area. That lateral surface area happens to be, if I were to take this off and peel it off, it would be a rectangle. Have you ever taken the label off of a can? Wow, when it's on the can, it makes a circle, doesn't it? Makes a hoop. When you take it off the can and lay it out, chink, you cut it, it makes a rectangle. Alright? You ever cut cans, make them flat so you can make something else out of them? Same thing. Cut off the bases, the top and the bottom. Cut them down the side. Oh, it makes a rectangle. That's all a cylinder is a rectangle connected without any edges or corners. Circles on the ends. So what we have is the bases of a cylinder are circles. The lateral surface area, well, we can still calculate the lateral surface area. Lateral surface area for a cylinder is just the side without the circles. Okay? Or the total surface area would be the two bases added to the lateral surface area or the side. Again, if you are asked to find the surface area, then find TSA. Lateral surface area, as we saw before, is capital PH. Well, what's perimeter? Perimeter of a base. Base is a circle for a cylinder. So perimeter is pi d. It's a circumference. Okay? Let's just put that in there. Let's just put it straight in there. P equals C equals. P equals circumference equals pi d equals 2 pi r. However you want to say it. H, it is a perpendicular distance between the bases. Well, this happens to be a right cylinder. Why? Because the axis, what's the axis of a cylinder? Segment that connects the center of both bases. If I were to put a stick, a rod, through the center of both bases, that rod would be perpendicular to both bases. Therefore, this would be known as a right cylinder. It's not leaning like an oblique would. This is a right cylinder. H is the perpendicular distance between the bases. In a right cylinder, that's the length of the axis. Okay? Now, what's total surface area? Total surface area is capital PH plus 2B. Where B for cylinders is the area of a circle. What's that equal? B is pi r squared. What's another way we could write this? Circumference times height plus 2B. P is a circumference, where C stands for circumference, okay? That's all there is to circle. We're going to use everything that we had before. Okay? There's only one name for these things. It's sort of hard to have a pentagonal cylinder. Sort of hard to have a triangular cylinder. Can't have a hexagonal cylinder. It's just a cylinder. Why? Because the bases are always going to be circles. Let's do some samples, and we'll be home free with this.